Okay, turn to page 12 and create these two graphs. Pause the video so you can try it yourself first. Okay, so the step one should be the midline. Actually, let's fill in these properties. So the amplitude of number one is 2. The negative is a reflection, but that is not specifically the value of the amplitude. So the 2 is the amplitude, the negative is the reflection. The period, so we have a 1 in front of x, so the period would be 2 pi divided by 1. And the midline is going to be up 4, so that's at y equals 4. So the vertical scale, we start with the midline. And then we count the amplitude 2 up from the midline to 6 and 2 down to 2. And now we need the horizontal scale. And since there's no period change, we're going to use our quadrantals. And our 5 critical values. So the pattern of points is the function type and the reflection. So we've got cosine would normally start at the maximum, but with the reflection, it now starts at the minimum. It goes to the midline, up to the maximum, to the midline, back to the minimum. And when you connect your points, you have to make sure to turn the minimum around at the bottom here. Since this graph is bounded above and below, we need to make it appear that these minimums are the absolute bottom of the range. All right, let's check your answer to number 2. For amplitude, it's 3. That's the vertical dilation number in the front. Period, again, would be 2 pi because there's no period change with the coefficient on x. And this midline is down 5 at y equals -5. So -5 is our midline. We're going to count up 3 and down 3 from the midline. Our horizontal scale is again going to be the quadrantals. And our pattern of points is a sine, so that starts midline, maximum, midline, minimum, midline. And there's our sine graph. Okay, so today on page 13, we're going to have some more horizontal changes that we didn't get a lot of in our prior class. So for number 1, let's start with the midline. And that is 0. There's nothing added or subtracted at the end. So now let's count our amplitude. We're going to go up 2 and down 2. And this time, this function has an 8 as the horizontal dilation. So that's going to change the period. So the new period is going to be 2 pi divided by the b value, which is 8. So that's a period of pi over 4. And what this means is we're going to have 8 waves where we'd normally have 1. So the end of our period is pi over 4. And then we need the halfway point. So halfway between 0 and pi over 4, I could find the midpoint. You could also mentally do this, but if you like a calculation way, the way to find the middle is going to be 1/2 times adding up the ends. So this is 1/2 of pi over 4. So that gives us a midpoint of pi over 8. Okay, we need another midpoint. So now I need halfway between 0 and pi over 8. So that's half of pi over 8, which is pi over 16. And then we have one more halfway. And now you could calculate the midpoint this way, or I'm going to count it. So I see I have 1 over 16 pi as my first. Pi over 8 is the same thing as 2 over 16. Then we would have 3 over 16 and then 4 over 16. So the missing midpoint here would be 3 pi over 16. So if you can count your scale, that's a lot easier than finding the middle. All right, so now we need our points. It's a cosine function, so that's maximum, midline, minimum, midline, maximum. And that's, okay, let me make this a little more see-through. Maximum. This way you can still see my x scale. All right, let's try number 2. All right, you pause the video here, lay out the beginning of your graph. Okay, so you should start with a midline at -1. That's that horizontal, that's that vertical translation at the end. The amplitude, we're going to count up 3. 1, 2, 3. Count down 3. And then there is a 1 in front of x, which means there's no period change. So your x scale should be your quadrantal angles. I just put them above the x-axis since my midline was so close. And now our pattern is a sine pattern, but reflected. So we're going to start midline, but then go to the minimum, back to the midline, to the maximum, to the midline. And there is our reflected sine graph. All right, number 3. Pause the video and try to lay out all the properties. So we start with a midline of 0 and an amplitude of 2. So we're going to go up 2 and down 2. There's a period change. So the new period is going to be 2 pi over 1/4, which means we're going to get 1/4 of a wave where we normally have 1. Dividing by a fraction is the same thing as multiplying by the reciprocal. Multiply numerators, multiply denominators. And so we get a period of 8 pi. So now I need the middle. So in between 0 and 8 pi is 4 pi. I need the middle again. In between 0 and 4 is 2. And then the last one, so we've got 2, 4, 6 pi, and then 8 pi. All right, put your points in the sine pattern. Midline, maximum, midline, minimum, midline. All right, and number 4, try this graph. Pause the video again. You got a midline at up 3, an amplitude of 1, no horizontal dilation to change the period, so we've got our quadrantals. And now it's a reflected cosine pattern, So that's minimum, midline, maximum, midline, minimum. And turn the minimums around so that they look like the bottom of a valley. You have to make sure you show that that's the minimum point. Okay, page 15, just state the transformation. So we're going to go back to those algebra words about transformations. Pause the video and see how many for number 5 you can list. I think I'll type them instead of writing them. Okay, so for number 5, we've got a vertical dilation of 3, a horizontal dilation of a quarter, because it's the reciprocal of that coefficient, that multiplier, plus 3 pi over 4 shifts the graph to the left 3 pi over 4, and the 2 at the end is down 2. So if I was going to translate those to sine and cosine words, I know this is not specifically in the question, but we can work on it now. That vertical dilation of 3 is an amplitude of 3. The 4, that horizontal dilation, gets you a new period. And that new period, I guess I should use the pen again. We would get 2 pi divided by the b value, 2 pi divided by 4. So the new period would be pi over 2. Left and right is called a phase shift. So this pattern would start, it would slide with a phase shift to the left, 3 pi over 4. And then down 2, that means a midline at y equals negative 2. Okay, so let's try that for number 6. State the transformations and then state the sine cosine properties that correspond to those transformations. All right, so we've got a vertical dilation of 3, which means an amplitude of 3 again. We've got a horizontal dilation of 1/2 because you reciprocal the multiplier. So that means the new period is 2 pi divided by 2, which is just pi. That means we had 2 waves where we would normally have 1. So if the period is pi, we're going to get 2 sine waves where we would normally just have 1. The plus pi over 4 is left pi over 4. That's a phase shift to the left. And then up 5 is a midline at y equals 5. Okay, so some answers here. Your homework is page 16. This is old. You can ignore that. You are going to match the 10 equations at the top with the 10 graphs below.